Hello students. Okay, so today we are going to talk about a very important topic for your NEET examination. That is one of the way to determine that how much nitrogen is present in an organic compound. Okay, and the method is called Kjeldal method. There is another method also, that is Dumas method. So that we have already published that video, and for that video you check the description section. So in this particular method, it little bit of different way the approach is done. Like in Dumas method, it was the way to first you estimate as a molecular nitrogen, then you convert with compare with STP, then you calculate its moles. But here in this case, the important thing is that the nitrogen is estimated as ammonia. Okay, nitrogen is basically estimated as ammonia. Okay, so when we are talking about ammonia, that means here definitely in order to estimate ammonia, you need an acid. Fundamentally, if I think, you need an acid, maybe dibasic acid, maybe it's monobasic acid. But for our discussion purpose for here, we are considering that we have taken a sulfuric acid here. Okay, sulfuric acid. And in order to neutralize the sulfuric acid, that excess is there. I will come to that context later. What we need a base. That is, we have taken, let's say, suppose sodium hydroxide, another base. Okay, so this is the main overview, but let me discuss in little bit of details. Suppose the point is that this is your organic compound. Okay, this is your organic compound, and the, let's say, the weight amount is W0. Okay, now beta, this W0, what we do, whatever nitrogen is present here, we convert into the ammonia. We convert into the ammonia. Now what we do, this particular amount of ammonia, we titrate against excess amount of sulfuric acid. Excess amount of sulfuric acid. And you will know, interestingly, यहाँ पे, that how much volume of the sulfuric acid you have taken, we know, and what is the strength of the sulfuric acid we have taken, that also we know here. Okay, next part is something like that. Once it is excess sulfuric acid reacts with the ammonia, we get the how much sulfuric acid is left. How much sulfuric acid is left. Now the question is that how much sulfuric acid is left, how we will know that how much sulfuric acid left? We will treat this sulfuric acid, with a fixed volume, of sodium hydroxide, and we will check that how much NaOH is consumed. How much NaOH is consumed, that we will check. That's a very beautiful way. Now in your exam, the problems which will be given, in that case you will be knowing three things. Okay, number one, they will give you the data of how much sodium hydroxide is consumed and what is the strength of the sodium hydroxide. They will also give you that how much the acid is used to neutralize the ammonia. Okay, and they will also give you that how much the organic sample we have taken. So whenever you are doing a problem, approaching a problem for Kjeldal method, my advice is that you should go from backward direction. Let me explain that thing with a problem, and I will show you that how it is done. Okay, now the problem I have taken here, although here the acid which I have chose here, that is hydrochloric acid. Okay, and that means the basicity is equal to 1. Similarly, your sodium hydroxide is chosen, so your basis acidity, so the acidity will be is equal to 1, right? And we know that for HCl and sodium hydroxide, both of are monobasic and monoacidic. So whatever their normality is given, that is basically nothing but your molarity as it's same. Okay, acha. Now see, what we will do first, as usual, we need to target a numerical. You basically write that what things are given. Okay, so what are given here? Let me write it here. So the given things are here. The W0 is given your 1.525 grams. Okay, and your M1, that is the molarity of your HCl, that is your 1 molar. We know that 1 normal is basically is equal to 1 molar, right? 1 molar, and the volume of the taken hydrochloric acid is your 30 ml. 30 ml. Similarly, the sodium hydroxide consumed, that is your M2 of your N by 10, that is 0.1, and the volume it is consumed, that is 120 ml. So we have the data. जो data हमने पहले slide में बताया था, exactly those data is given here. Now we will check that how much it is happening or how much nitrogen is there. So पहले हम क्या करेंगे? First we have here we have our beautifully sodium hydroxide we have, and we know that whatever sodium hydroxide is consumed, that is basically the amount of the your hydrochloric acid which is present in excess. So directly here we will write the excess hydrochloric acid. Okay, and that is basically is equal to the total amount of sodium hydroxide consumed, that is 120 multiplied by 0.1, that is your 12 millimoles. 12 millimoles, correct? Now since this is the excess hydrochloric acid, and we know that the total hydrochloric acid was taken is your 30 millimoles. Total hydrochloric acid was taken 30 millimole. Then what we can write here? Used HCl to neutralize ammonia, for ammonia, that is your 30 minus 12, that is equal to 18 millimoles. 18 millimoles. And beta, interestingly, this is basically is equal to your ammonia produced. This is equal to your ammonia produced. Okay, so simply if I put this logic again, then if this is the total amount of ammonia produced, then beta, what we can say that 1 mole of ammonia is basically is equal to 28, is equal to 17 gram. Okay, so what we can write beta, 18 into 10 to the power minus 3 moles is equal to your 17 multiplied by 18 multiplied by 10 to the power minus 3, that is equal to your 0.309 gram of ammonia. Okay, now simply we also know that in 17 gram ammonia, which contains 14 gram nitrogen. So if I go by that logic, then 0.309 gram ammonia contains 14 by 17 multiplied by 0.309, that is equal to, which will come 0.252 gram of nitrogen. That means here we already calculated that what is the amount of nitrogen present in the organic compound. So beta, the percentage of nitrogen will be is equal to 0.252 divided by the amount of the weight is given, that is 1.525 multiplied by 100, right? So if you calculate, this will be coming approximately 16%, which is your answer. Okay, so this is how you target a problem in Kjeldal method. Okay, now see, so overall, if I think in this way, in comparison to Dumas method, Kjeldal method is much more convenient, much more easy, and it is much more gives you a better estimation of the nitrogen. Okay, so I think this will clear your doubt that how Kjeldal works and how to tackle the numerical problem. So still, if you have any queries or any doubt or any questions related to this or any other things, okay, so feel free to write on the comment section, like this video and share with your friends so that they can also understand this thing. Okay, so fine everyone. So thank you from my side. So take care. We will see you in the next time.